Welcome back. We're going to go ahead and start Unit 1 in our geometry course called Introduction to Logic and Euclidean Geometry. In this unit, we are going to learn some of the basic pieces of geometry. So what I've done for you is gone ahead and filled out the map for the unit. And this first lesson is going to be 1.1 points, lines, and planes. So we're going to learn what a point looks like and how to name it, what a line looks like and all its relatives and how to name them, and what a plane looks like and how to name them. And then we'll move into the different stuff. So there's where you can see kind of the roadmap on when quizzes will show up and when we will have our unit test. All right, so let's go ahead and get started with points, lines, and planes. I do believe I attached the foldable for you should you choose to use it. So 1.1 points, lines, and planes. Let me just kind of cover that up and let me zoom in so that you can see better. Okay, so in geometry, we have some undefined terms. Oops, excuse me. My paper wants to fall. There we go. We have some undefined terms, and that would be a point, a line, and a plane. They're undefined because we just have to agree that we understand what a point is, that we understand what a line is, and we understand what a plane is. We have to agree on what they look like because they have no definition, no dimension. So we can't tell where they start and where they stop. So a point, it has no dimension. There's no length or width. It looks like a dot. You graphed them on a coordinate plane on an X and Y axis in algebra. You will do that again in algebra 2. In geometry, we just talk about points in space. So the difference that you're going to see in geometry is you're going to see a capital letter next to that point. And that capital letter, and in this case it's A, is there for naming purposes so that we can all look at the same point, the same dot on a piece of paper. So if I were to name this point, I would simply call it point A. And you have to use a capital letter because that's just universal. That's what all the mathematicians around the world use. We don't use lowercase letters. We use uppercase to name. I've also seen it just simply a capital A, and you don't have to write the word point. So if you see just one capital letter, we're probably talking about a point. Okay, moving on to a line. A line has one dimension, length, and it extends without end in two directions. So I'm going to underline that. Extends without end in two directions. This is where it becomes very important that when you draw a line, you show me that it does not end. And you're going to show me that by adding the arrows to both ends. That's how you're going to show me that it extends in both directions. Without them, this line becomes something else. So, what you're going to see when we get to the defined terms is that what you may have graphed in algebra was not technically a line because you did not add the arrows to both ends to show that it continues forever. Okay, to name this, I could write the word line, but mathematicians came up with a symbol. So the symbol is a horizontal line with arrows at both ends. And I start with that. And then notice that this line has 3 points, A, B, and C. All I have to do is pick 2 of them. So one name for this line is capital A, capital B, with the line symbol above it. And I would read this as line AB. I could also have called this line AC. It has to have the arrows above. You have to have 2 of the letters, 2 of the points. The third name I could have called this one is line BC. There are 3 more names for this line. There are 3 more names for this line. So I'm going to put dot, dot, dot. And the 3 more names are coming back and reversing the letters. So I could come back and call this line BA, line CA, line CB. All 6 of those names are correct. All 6 of those names are correct. And they all talk about the same line. Okay, a plane has 2 dimensions, length and width, and it extends without end, and there's no edges. Now, normally we think of a plane as being a parallelogram, so that's what you will normally see depicted, but actually it's still going out this way, it's still going out that way, it's still going up, it's still going down. Notice there are 3 points on this plane. A, B, and C are my 3 points. So if I were to name it, I could simply call it A, B, C. The 3 points have to create a triangle for you to connect them together. Okay, they have to create a triangle. They cannot create a straight line. They could not look like this. They have to create a triangle for you to use them to name them. You can put them in any order. I just like alphabetical, but I could have called it BAC. I could have called it CAB, BCA. It doesn't matter the order. They're all correct. Now, some of you might be saying, well, Miss, there's that M in the corner. Notice the M is in the corner. It could be in any of the 4 corners of our parallelogram, and it does not have a dot with it. This is not a point. This is not a point. So why is that M there? Well, it's there for us to name it. I could simply write the word plane and then put the capital M. That's another name for this plane, plane M. Okay? All right, we're going to go through some properties that lines and planes and points have, and then we're going to get into some examples. Through any 2 points, there exists exactly 1 line. So I can come back to my plane up here and I can create a line through AB, through BC, and a 3rd one through AC to create that triangle. You use any 2 points on a line to name it. Any 2. I can put as many points on the line as I want, but I only need 2 of them to name it. Okay? Through any 3 points, not on the same line, so that's my triangle, because they're not on the same line, there exists exactly 1 plane. 3 points not on the same line, there exists exactly 1 plane. You will use those 3 points that are not in the same line to name your plane. Okay, so yes, there is a plane around this line, but I cannot call that plane ABC. That's basically what the rule says. So I would have needed a 4th point D to be able to name the plane around this line. Okay, before we go into the example, here we go. We got to talk about, points being collinear points and points being coplanar points. Okay, so when my points are collinear, they are on the same line. Same, linear line. Okay, I'm not trying to trick you with the terminology. So coplanar, the points lie on the same planar. And you'll be asked different questions like, you're going to look at the next example. Are these points collinear? Yes or no? Okay. All right. So here is our example. And what we see in our example is a picture of a plane with some points on it and some lines on it. Now notice that there's 1 line that is laying on the plane. And then there's this line here. And let me zoom in just a little bit more. Notice that it has these dashed pieces. That means it is going through the plane. So kind of imagine a piece of paper, like you had a piece of paper. It would be like you stabbed the paper with your pencil and your pencil was doing this. And you had your paper around your pencil. Okay, that's what's happening. All right, name 3 collinear points. 3 collinear points. So if I go back up and look, collinear means they're on the same line. D, E, F. D, comma, E, comma, F. I don't want to put them all together as DEF because that would be a name of a plane. If I don't have the separation, then if they're all together without the commas, I'm talking about a plane. And I have to really be strict about that, okay? Name 4 collinear points. Oh, sorry. Name 4 coplanar points. So can I use D, E, and F? Yes. The 4th one would be G. R is not a point because it's in the corner and it has no dot. It has no point with it. So D, comma, E, comma, F, comma, G. I can't just put them all together. That's wrong. Putting them all together without any space of the comma is not correct. Okay, name 3 non-collinear points. Okay, so 3 points not on the same line because they added that word non. I can still use D and E or E and F, but I cannot use D, E, and F because I know those 3 are collinear. So I could say D, E, and I could say G or H. It doesn't matter. I just need one of them to not be on the same line. I could have done G, E, H. There's lots of answers to that 3rd question, and all of them are correct. So G, E, H would be correct. G, F, H would be correct. There's lots of correct answers. But all I need is one that is not collinear to the other 2 to be correct. Okay, which point is between D and F? Well, that's easy to see. E. Name a point that is not between D and F. Well, I could put H. It's hovering up above. It's not technically between them because between would mean it was right in the middle on that same line. You could have also put G. G is a correct answer as well. R is not a correct answer because remember, R is not a point. Notice N down here. In lowercase, that's naming the line. That's naming this line HE. Okay. Are collinear points also coplanar? Well, I answered that question before, and the answer is yes. Okay. I can put a plane around collinear points, but to name the plane, I need this guy in the corner or I need a 4th point on the plane. That's really the only purpose. So yes, collinear points are also coplanar, but I need the 4th point that's not collinear to be able to name it. Are coplanar points also collinear? Not always. There are some situations in some pictures where points can be coplanar, but not linear. Okay, so not always. Sometimes yes, sometimes no, and you can see that here. Yes, no. This one's not collinear, so no. Okay. All right, moving right along. Let me get my thing in here so that I don't go too fast for you. Let's take a look at the defined terms. So there are also some defined terms in geometry. And the first defined term that we have is a line segment. So we're moving into the defined terms and we're going to move into the segment, the line segment. Now this is considered, let me get the focus back. Come on. There we go. This is considered defined because I already kind of have an idea what a line is, okay? So since I know what a line should look like in my head, I can now define exactly what a segment is. Line segment AB or BA consists of the end points A and B and all the points on line AB that lie between A and B. So when I talk about a segment, it looks like this. This is a traditional segment. Notice it starts at one end and it stops at the other. It has no pause in it. If I were to name it, this would be the symbol. No arrows because it starts and it stops. It has two endpoints, and I'm going to put the two endpoints there. It only has two names, segment B, A. There's no rule that says one letter has to go before the other. I can also see a line segment on a line like this. So I could actually talk about this line and then bust it into segments. So there's a segment here between A and C. It would just be like chopping off the rest of the line. There's a segment between C and B, and I just chopped off the rest of the line. And then there's the segment between A and B, and I just chopped off the rest of the line. D is not part of the line. It is not part of any segment. I can connect C to D. I can connect B to D. I can connect A to D to create more segments, but they're not drawn for me, so I'm not going to at this point. But D is just there as a point, and then I can talk about segments in my line, okay? All right, the other one, the other defined term is a ray. Okay, I can have a ray. And ray AB consists of the end point. So notice now I only have one end point A and all the points on line AB that lie on the same side of A as B does. Okay, so take a look at my two rays. Here's my ray, my first ray, and it has the points A, then C, then B if I read it from left to right. When I name a ray, I must always name the end point first. So that's the end that has no arrow. So I have to put A first, and then I could put either C or B. I like to go the farthest, so I like to call it AB, but you could call it AC. That's a perfectly fine name too. And your symbol for ray is a line, a straight horizontal line with an arrow on this end. The arrow must always go on this end. The arrow does not flip-flop back and forth. That's not how it works. We all agreed as mathematicians many, many, many years ago that this is the symbol for ray. There is no other symbol. Okay. All right, so the difference between the next one is my end point. Notice A is not the end point anymore. A has the arrow after it. So the end point here is B. This is tricky because the name for this one is B, and then I would go to A. But you could have done BC, and the symbol is straight, and the arrow is here. Notice my symbol does not match my picture. That's okay. It's supposed to be that way. It has to be that way because this name does not represent what the picture looks like. That's not how it works. Okay? All right. I just have a few last things to talk to you about, and then you guys can go ahead and work on, oh, well, I'll see you to work on the assignment next class. Sorry. Okay. So CA and CB are opposite rays. If C lies on line AB between A and B. So what I'm going to do is I'm going to draw a line. So it says it is on line AB. There we go. So somewhere here is A, somewhere here is B, and C lies between them. Now, between does not mean exactly in the middle. It could, it does not have to. So I can put C anywhere I want, just as long as it is in between them. It does not have to be in the middle, okay? Opposite rays are co-linear, two L's, there we go, co-linear. So to be opposite rays, I'm going to have one that starts here at C and goes this way. there is ray CA that they talked about. Let me grab a darker highlighter than my yellow. Oh no, let me use my yellow. I think it's okay. And then I also have the one that starts here at C and heads this way towards B. This is my ray CB. Together, they form the line, okay? Because they share that C, notice how the color at C kind of changed because it has both of those highlighters in it. This is what opposite rays look like. All right, let's move into our next example. Draw 3 non-collinear points, J, K, and L. So whenever I'm told to do that, I like to draw a rectangle. So I'm going to do J, K, L, just kind of in order. Now it says, then draw line JK. So that would mean I'm going to find the letters J and K, and I'm going to connect them together to create a line. I'll make sure that when I do the assignment that you can tell if it says line or segment or point or ray. Then draw segment KL. So we're going to find K and L. Now a segment stops and starts, so I'm just going to simply connect them together, and I'm not going to extend it. There's a segment. And the last one, let's draw ray LJ. So I'm going to take L and J. Because it says L first, L is not going to go this way. It has to go that way because that's what a ray does. L is the end point. So I could ask you a question like this to create these, okay? More than likely, it would be a multiple choice. Which one is correct? Which one of the pictures is correct is what I'm going to do, okay? All right, here's some true or false questions. Let me zoom in just a bit. Based on this plane. So I have 2 planes, one on top of the other. There's some space in between them. I have some lines on each of them, and then I have a line connecting them together through the points E and B. So are points A, B, and C collinear? Are the points A, B, and C collinear? False. They're not collinear. They're not on the same line. C is hanging off up above. They are coplanar, though, because they're all on this bottom plane. Are points A, B, and C coplanar? True. There we go. And does point F lie on line DE? Does point F lie on line DE? True. That is true. All right. Last ones. We have one last definition. Let me find it. There we go. 2 or more geometric figures intersect if they have 1 or more points in common. The intersection of the figures is the set of points the figures have in common. All right, so the intersection of 2 different lines, and I'm going to go ahead and draw this. Uh-oh, I lost my ruler. Okay, I'll do the best I can to make them straight. There's one line. Here's a second line. Okay. This is the only way 2 lines can intersect each other, and they can only intersect each other right here, and this is at a point. Lines can't do anything else. They cannot intersect at 2 points or 3 points or at a ray or at a plane. 2 different lines intersect at a point. The intersection of 2 different planes, notice I changed the wording here, is a, let's take a look. Here, they kind of drew us a picture for this one already. So here's my first plane, and here's my second plane. Okay, so notice it looks like they are mixing here and here, right? But I also know that through any 2 points, I can create a line. So every place in between these 2 points, that those planes are connecting together, they're intersecting. So they intersect in a line. It's kind of like if you take your fingers and lace them together, you can actually see it where your fingers get laced together. They're meeting everywhere there. They're not just meeting here and here at your index and your pinky fingers. They're meeting everywhere in between. Okay, so last example. Draw 2 intersecting lines. So I'm just going to do the crisscross X like I did before. Because I don't know, whenever I see 2 intersecting lines, that's what I think of, right? Label 3 points on the line. So I'm going to put 1, 2, 3. Let's call it A and C and E. And then I'm going to put 1 and 2 on this line so that I have 1, 2, 3 on this one as well. I'll call this one B and I'll call this one D to fill in my A to E. Okay. And name 2 segments of the line. Name 2 segments of the line. So I could pick either line. Let's focus on this one. There's a segment here between A and C. There's my segment symbol. And there's another segment down here, C and E. There's my segment symbol. Okay, or I could have gone to the other line and said DC or CB. It doesn't matter. Okay, name a non-collinear point. So what's a non-collinear point to this one? Well, it would be B or D. Or if you use this line, you would say A or E. They would be a non-collinear point. Okay, all right. I will see you guys next time.